Good morning, my fellow scientists. It is Monday, April 24th, 2017, and I want to talk a little more about the iron battery. I went ahead and constructed the prototype cell using the iron oxide particles I precipitated last week, and I will show you how I went about that. So I'm going to go through how I assembled my cell. I took some iron wire to act as my anode and wrapped it around a slide. Then I took some pencil lead graphite to act as kind of a spacer and connector, and use a little hot glue to secure it to a second slide. Once that's accomplished, you can see that the two align and I have my anode and cathode ready. At that point, I'm going to take some artist graphite, which I've confirmed is conductive, and I'm going to add about 2 grams to the precipitated iron oxide that I made last week. I'm going to stir that up and then apply that between the two pencil lead 0.7 millimeter spacers that I put on my second slide. And I made a pretty nice paste that I was able to spread out in that spacer. I smoothed that over as best I could with the back of my spatula, and there it is. There is the cathode. Now we're going to apply a paper spacer and wet that with a little bit of sodium hydroxide so that I have a good salt bridge between the two electrodes. Then I put a third piece of graphite into that paste in order to act as my current collector, and to which I can connect my voltmeter. I secured that with a little bit of hot glue and immersed the whole thing in a beaker of sodium hydroxide and connected my electrodes to my voltmeter and current meter. This is 2 charge-discharge cycles where I've applied 1.4 volts. You see a initial negative current, and then when I connect up a 1 kilo ohm resistor, you see a positive current above this background level, and this voltage decays in a sort of sigmoid curve. That sigmoid curve is important because it looks like a proper battery discharge curve, not like a capacitive discharge curve. So I think we have a real cell here, but we need to do a little further analysis to actually calculate how much energy was stored and calculate the efficiency of charging and discharging and so forth. But it's a good beginning. That's within the range I think is reasonable for iron oxide chemistry. It's a little high, so there's probably some capacitance that is contributing. There may be some effects of the graphite or the size of the nanoparticles on the potential that they contribute. So I'm not quite sure how to analyze that, but I'm going to start doing some more research tonight, try to interpret these voltages and currents a little better. I do also have a colleague down the hall with a much better battery tester that will cycle the battery through multiple charge discharges, and so I'm going to take it over to his lab and we're going to give that a try this afternoon. So thank you all for tuning in and watching the construction of the iron oxide battery. I hope that is fun and useful for you. If you like this sort of stuff, tune in tomorrow. We'll put up more videos about science and chemistry and batteries and do-it-yourself chemistry here in the Allen Lab.